Thank you for having this opportunity. This is Ayako Furuhama, National Institute of Health Sciences, NIHS Japan. I'll talk about the evaluation of Ames mutagenicity prediction for a chemical under the OECD QSAR assessment framework. First of all, the views expressed here are those of the speaker and not an official position of either NIHS or Food Safety Commission of Japan, FSCJ. OECD QSAR assessment framework, called QAF, is a systematic and harmonized framework for the regulatory assessment of QSAR models, predictions, and results based on multiple predictions. There are model and prediction principles. Accordingly, there are also model and prediction checklists to confirm each assessment element. Please note, if there are multiple predictions, result checklist to summarize the multiple prediction is required. I will talk about a case study to assess a chemical by using the checklist. This is our target chemical, this one. The Ames test report written in Japanese is available. The Ames test results are TA100 and TA1535 with and without S9 positive. This is an assumption for this assessment. We assumed to determine Ames mutagenicity of a target substance by using QSAR under an example regression. It assumed to be evaluated by an example assessor. For assessing an example regression, we define the purpose is screening, that is, listing up Ames equivocal or positive chemicals. We refer to draft guidance for Food Safety Commission of Japan, FSCJ for QSAR. Guidance of QSAR to evaluate mutagenicity as health impact assessment of food. Like ICH M7 guideline, two QSAR tools, statistical-based and rule-based, were used to evaluate overall mutagenicity. In this case, multi-model prediction, we need a result checklist. Additionally, we assumed QMRF and QPRF were requested by the assessor and provided by the model user. We used two QSAR tools. One was a static-based model of case router, Marcase Inc. Another was a rule-based model of oasis times, LMC. To simplify the discussion, we pick up a target substance with a positive Ames test result. These are assessment elements of a model checklist, except for 1.2, 1.3, and 2.3 highlighted in yellow. Outcome become fulfilled. In the case of case router, 1.2, 1.3, and 2.3 are not applicable or assessed. In the case of oasis times, 2.3 is not applicable or assessed. This is because that both are commercial softwares and not publicly accessible. Here, the models evaluated in this study are applied under the example regression. The models fill the requests for our target regulatory purposes. In this case study, the model checklists are easy to handle. The only issue is the transparency of the model for assessors who are not able to assess the models, but not an issue for users of the models. We might accept this limitation. According to guidance, for some regulatory purposes and with a valid justification, models that do not fill in an assessment element, AE, can also be accepted. From now on, let us focus on result checklist of this compound. This one. These are assessment elements for the result checklist. In the result checklist, outcome, uncertainty level, and weight of the assessment element were taken into account for the evaluation. We focus on two assessment elements, highlighted yellow. Those uncertainty levels become mediums with high weight. That is assessment element 2.1, substance within the applicability domain, and 3.4, performance of the models for similar substances. At first, 2.1, substance within the applicability domain, AD. Most commercial models tend to treat training data as confidential, and such data are not accessible, especially from assessors. Now, most models include functions to check if the target substance is within the applicability domain. It is detailed in some cases, but still verifying it independently is difficult in most cases. So, the uncertainty level of the assessment element for AD is practically no lower than medium according to current definition. Please note, according to the QAF guidance or checklist, AD uncertainty level low is the substance clearly falls within the applicability domain of the model. AD uncertainty level medium is the model automatically indicates that substance is within its applicability domain, but this cannot be independently verified. This is due to the definition. Next assessment element is 3.4, performance of the model for similar substances. We'd like to emphasize the difficulties to define similar substances for assessing 3.4, local performance. Maybe the definition is endpoint specific and regulation dependent. Tested analog with similar order of structures, that is, cyanic acid substituted with haloalkane groups, could not be found. Therefore, we define the halogenated alkane is an alert, and the chemical with the alert is locally similar one. In this case, we found 4 similar chemicals with Ames result. There are all positive both predictions and tests. These models have the same local performances. The checklist for this assessment element becomes outcome is fulfilled, but uncertainty level is medium. This is because of current definition. That is, uncertainty level low is similar substances with reliable experimental data are available, and model predicts them well. Uncertainty level medium is only moderately similar substances, or only one similar substance with reliable experimental data are available, and model predicts them well. So, in our case, similar substances, that is, cyanic acid substituted with alkane group, are not found, and moderately similar substances prediction is fine. That is again uncertainty level medium. Finally, we reached final result from multiple predictions. Result checklist. So, how to decide the overall outcome uncertainty when they are not consistent between multiple predictions? When multiple predictions show consistent result, it is basically thought supportive and expected to lower the uncertainty. So, we suppose it can be low. That is, only the uncertainty levels of 2.1 and 3.4 were medium. Other uncertainty levels for the assessment element is with high weight were all low in both predictions. The final result uncertainty level is low, and outcome the assessment is acceptable. There is a next step to continue case studies. Each guidance or regulation may accept the limitation of models and/or prediction is not always clear. Such limitations of models and prediction would be case by case and depend on endpoints, properties. But general rules will be required to fill the model's prediction and checklist as well as to construct the QMRF and QPRF. The optimization of QMRS and QPRF is required. The acceptance criteria of model and prediction assessment elements in each guidance regulation should be considered when an authority applies QAF and continuing the case study of QAF. For example, this is Ames testing data quality. Related assessment elements would be defined endpoint, that is, the quality of training data, predictivity, that is, the quality of external validation data, and reliability of the prediction, that is, the quality of similar chemical data. How quality level of Ames testing data should be included in QMRF and QPRF. Acknowledgement. We highly acknowledge all QAF group members, especially co-leaders, ISS and ECHA, and OECD secretaries. Thank you for listening.